Measures of dispersion. Our objective in this video, determine the range and standard deviation for a data set. Well, first off, what is a measure of dispersion? It is a number that describes how spread out the numbers are in a data set. Okay? Now, the two common measures of dispersion, number one, you have the range, which you've probably heard about. The range is simply the difference between the highest and lowest data values, and that obviously tells you how spread out things are. And number two, which might be new to you, is the standard deviation, roughly defined as the average distance each data item, is from the mean. Okay, we're going to use Desmos. There is a formula to calculate the standard deviation for a data set. We're not going to learn the formula. We're going to let a calculator do this for us. And in Desmos, we're going to use STDEV to find the standard deviation. Obviously, standard with ST and DEV deviation. Okay, let's take a look at how we're going to do this. So here we have it. This is kind of a neat example that looks at the ages of our first 6 presidents at inauguration and the ages of our last 6 presidents at inauguration. Okay, let's see. I know my first 3. This one's George Washington, of course. This is John Adams, and this is Thomas Jefferson. I forget 4 and 5, but I know number 6 is John Quincy Adams. I think he's the son of John Adams up here. And you can see these ages are all fairly close to one another. 57, 61, 57, 57, 58, and 57. So our first 6 presidents were almost all the same age when they were inaugurated. Let's find the range. Okay, so the range is the high minus the low. Okay, well the high age, or the highest value here is 61, John Adams. And the lowest value here is, well, we have a bunch of 57s. Just got to pick one of them. That's the lowest value. And we'll see that the range is 4. So this data is not very spread out according to the range. There's only a spread of 4 from the highest age to the lowest age. Let's compare that to the age of the last 6 presidents. If memory serves, this is George Herbert Walker Bush. He was followed by Bill Clinton, followed by George W. Bush, the son of George Herbert Walker Bush, followed by Barack Obama, followed by Donald Trump, and finally followed most recently by Joe Biden. And take a look at their ages. There's quite a discrepancy here. From the youngest, Bill Clinton, who was 46 when he was inaugurated, up to Joe Biden, who was inaugurated at the age of 78. Okay, let's take a look at the range for the last 6 presidents. Again, the range is the high minus the low. Well, I just said that Joe Biden was the oldest. The youngest is Bill Clinton at 46. And so the range for this data set of these 6 presidents is 32. Quite a difference here. Okay, so we can see that obviously the spread of the data, the spread of the ages for the first 6 presidents is significantly less than the spread of the ages for the last 6 presidents. Okay, so that's one common measure, is the range. As we move forward to begin to discuss normal distributions, they involve the standard deviation, which is a bit more specific. As you see here, you're taking you're taking the mean, and you're kind of coming up with the average distance that every number is from that mean. It's a little bit more informational, if you will. Let's remind ourselves. In Desmos, the mean is simply the function mean. We saw that in a previous video. The standard deviation is this function STDEV, standard deviation. Okay, so let's find the mean. And we're going to use Desmos to do this. So I'm going to pull this aside and pull out Desmos. Get it into here. I hope I've got it. Yep, we're going to be focused on the top left, of course. Okay, so I'm going to do this with a table this time. So I'm going to go into here, press the plus, keep the plus button up here, the add button, and I'm going to add a table. This is another way to find these different measures. And in column X1, I'm going to put the ages of our first 6 presidents. Okay, so 57 was George Washington. Tap the next row. John Adams was 6. Whoops, I don't want to press times. I want to press 61. Tap the next row. Thomas Jefferson, 57. And then go down. The next one was 57. Maybe James Monroe. I forget exactly. And then a 58. And then John Quincy Adams at 57. Whoops, not 58. How about 57? Okay, so there are those 6 presidents. I put them into the X1 column. So I'll go down to row 2 and tap it here. And I'll go into my functions. And I'll say I want to find the mean. So I'll press the mean under the statistics menu. I'll press mean. And now I can just select the column heading. So X1. So press X. And then press 1. And it looks to X1. I'll close the parenthesis. And it looks to X1 and it says find the mean of the values in column X1. Well, the mean is 57.8. Okay, so I'll come back over to here and get myself hopefully straightened out. The mean is 57.8. Okay, now, what is the standard deviation? Okay, STDEV, we'll let that abbreviate standard deviation. And let's go back to Desmos. Okay, and now that the numbers are already here, I can find the standard deviation for the same column of numbers. I'm going to go to row 3 and tap in there. Go back to my functions, and under stats, right here is the standard deviation STDev. I'll press STDev, and again I'll press X and then 1, and it'll make a sub 1 for me automatically. And you can see that the standard deviation for the data in column X1, which is the ages of the first 6 presidents, is 1.6 to the nearest 10th. Okay, back to here. So the standard deviation, whoops, let's get this straightened out if I can, is 1.6 to the nearest 10th. All right, so again, what does this tell us? We have the mean, which is a touch below 58. And we see that again, roughly the average distance that each of these data items is from 58, is from 57.8, is approximately 1.6. They're all extremely close. That's a very small number. You only have to go 1.6 in either direction to capture the average distance. So this standard deviation gives a very tight distance, a very tight, distance from the mean, if you will. Okay, let's take a look at the last 6 presidents, and we'll do both, okay, at the same time. So back to Desmos. Now this time, again, I could do X1. I can do a number of different things. I'm going to choose to go to the Y1 column. Doesn't really matter. I mean, I'm obviously graphing some points, but I'm not going to worry about the graph too much. And so I'll put in the 6, our 6 most recent presidents. So 64, 46, 54, 47, 70, and 78. So there are the most recent 6 presidents. I'll scroll here because now I want to find the mean, but I want to find the mean of column Y1. Okay, so I'll go back to functions and select mean. And let's put in Y sub 1, type in Y and then the number 1. And the mean here is 59.8, rounded to the nearest 10th. And let's do the same thing with the standard deviation. So I'll tap in row 5. I'll go back to functions and I'll press stdev right there. And again, y1. And the standard deviation is 12.96, which rounds to 13 to the nearest tenth. Okay, so that's how you can use Desmos to find the mean and the standard deviation. That's one way. You can put it into a list, into a table, and then call up that table by its heading. All right, back to here. All right, so we found out that for the last 6 presidents, the mean is equal to 59.8 to the nearest tenth, and the standard deviation to the nearest tenth is 13.0. Now I want to notice something here. We can see this in the range that we're going to have quite a difference. Notice that the means, the average age of our first 6 presidents and our last 6 presidents are quite close. You know, we're only off by a couple years here. Okay, they're very close to one another. So the mean's not telling us much. Now the range is telling us something that really they're quite different. You know, these obviously a range of 4. These presidents have ages that are quite close, and these presidents with a range of 32 are quite different. But the standard deviation will tell us the same thing with respect to the mean. Okay, again, a very tight standard deviation of 1.6 years. And this one is saying that roughly the average distance that every one of these presidents' ages is from the mean is about 13 years on average. Of course, you know, Joe Biden is 18 years. Looks like Bill Clinton is it's about 14 years. And the other ones are a little closer, but the average is approximately 13. So that gives you the two measures of dispersion. Coming up, we look at normal distributions. We're going to pay particular attention to the means and the standard deviations, because in normal distributions, that will tell us quite a bit. So we're going to be focused here on standard deviations as we move forward.